Mars wasn't always a cold and barren world ruled by raging dust storms covering the entire planet. Instead, it was warm, had lakes of liquid water, and was possibly habitable for a short period of its history. This dramatic transition of the red planet is generally attributed to the loss of its magnetic field. A planet's magnetic field is a fundamental ingredient that decides the course of events there. It is an entity that can cause the difference between life and death. The Earth's magnetosphere wraps Earth like a protective blanket. As the energetic solar wind strikes the magnetosphere forces it to flow around the planet instead of reaching the atmosphere or the surface, preventing the solar wind from stripping away Earth's atmosphere. Without it, Earth would be dry, dead, and barren, just like Mars. But if Mars once had a strong magnetic field, what went wrong with it? How did a warm planet become a cold, dry, and barren world? And most importantly, is this going to be the Earth's ultimate fate? To understand what went wrong with Mars, let's have a look at our planet first. On Earth, the magnetic field is produced by the dynamo effect. We know that the Earth has a solid inner core and an outer liquid core. As heat flows from the inner to the outer core, it generates convective currents in the outer liquid core. These currents further flow in patterns driven by the planet's rotation. And eventually, this flow of current generates a magnetic field, and the Earth develops a magnetosphere. Scientists believe that a similar phenomenon should have created a magnetic field on Mars in the past. And to confirm their hypothesis, they used data from NASA's InSight lander on Mars. InSight is a robotic lander specifically designed to study the deep interior of the red planet. It was launched on May 5, 2018, and is still actively studying the geological evolution of Mars. So far, InSight has gathered some crucial evidence regarding Mars's interior structure. It suggests that the Martian core is larger and less dense than previously thought. Moreover, it hints at additional lighter elements such as hydrogen in the core. This study was contrastingly different from the previous models that never included the possibility of the presence of hydrogen in the planet's core. After obtaining critical data from the InSight lander, researchers performed an interesting experiment. First, they prepared a sample matching what they think Mars's core was once composed of: iron, sulfur, and hydrogen. Then, the sample was placed in a device called a diamond anvil cell, which compressed it between two small diamond plates. The DAC can subject microscopic pieces to pressures of hundreds of gigapascals. Further, they used a laser to heat the sample and simulate the conditions inside the Martian core. Finally, as the team subjected the sample to higher temperatures and pressures, they used X-ray and electron beams to track the changes in the material. And to their surprise, it was found that not only did the sample melt, but the composition of the material also changed. The experiment's results can be examined based on miscibility. Materials are miscible if they create a homogeneous mixture after getting mixed up. However, if they don't make a homogeneous mixture, they are immiscible. Iron, sulfur, and hydrogen were miscible in the beginning, but as the temperature and pressure conditions changed, the initially homogeneous iron, sulfur, and hydrogen separated into two different liquids with great complexity. One of the iron liquids was rich in sulfur, while the other was rich in hydrogen. Amongst these separated liquids, the denser one stayed at the deepest part, while the lighter one migrated upwards and mixed with the bulk liquid core. The movement of these liquids generated some convection currents that are still going on inside Earth, And this is a possible idea why Mars also had a magnetic field in the past. But these currents only lasted for some time, and so did the Martian magnetic field. As the two liquids separated, there was no motion to fuel the convection currents, and at the same time, gravitationally stable and compositional stratification might have developed in the region where liquid separation took place. Eventually, Mars's entire core became stratified, and convection ceased. In other words, as the two liquids separated, there was no more convection and eventually no more magnetism. In this way, Mars was doomed with nothing left to hold its atmosphere. This event is believed to have occurred 4 billion years ago. Mars's core is inactive now, but another segment of InSight's data has something else to say. Time and again, InSight has found Mars to be rumbling with quakes. Recently, a team of researchers detected 47 new seismic events coming from the Cerberus Fossae region. However, since the quakes didn't follow any particular pattern in the timings of their occurrence, it was clear that they were not a result of the planet's interaction with its moons. Moreover, the quakes occurred repeatedly at all times of the Martian day. This suggested that the movement of molten rocks in the Martian mantle triggered the Mars quakes in this area. Research also found this region to be volcanically active in the last 10 million years, and this activity is attributed to the repetitive movement of magma in Mars's mantle. It indicates that Mars is more seismically and volcanically active than we thought. So far, InSight has been a great asset in understanding the geological evolution of Mars. But unfortunately, the lander is facing some serious challenges as the red planet's raging dust storms have taken a toll on its working. There's a lot more dust in the Martian air, interfering with solar panels charging. As a result, on May 7th, the power level of the solar panels dipped below the limit where safe mode was enabled. Following this, NASA plans to put InSight in low power mode to detect seismic events in July 2022, so only the most necessary functions of the lander will operate during this time frame. After that, InSight will work on low power mode until December 2022, after which its operational period will eventually end. Mars is an intriguing world for us. Understanding its activity and evolution is vital in designing future missions for human civilization. The questions are endless, and so is the quest of humanity to find an answer to them. Do you think Mars can be our second home in the future? Let us know your thoughts in the comments section. If you enjoyed this video, make sure to like it and subscribe to our channel for more episodes of the Sunday Discovery series.